my name's Ian Fette. I'm a product manager on the Google Chrome team, and I'm very happy to be here to talk to you about HTML5, a lot of the new capabilities that you all can take advantage of in your applications, and to sort of give you an idea of what's possible. And to highlight this, I want to show you that this is actually an HTML5 website. All of my slides are in HTML5. This is not PowerPoint. This is running in the browser. I'm going to go full screen because it looks better, but I just wanted to highlight that up front. Look at what's happened over the web over the past few years. Most of you probably know this, but starting off in the mid-90s, we got the ability to add images and links to the page. This is all very exciting if you're coming from Gopher. But to most of you in the audience, and especially to the younger audience members I see who are like, what the heck is Gopher? That might not be so exciting. Later on, we get JavaScript added. We start to see Ajax applications like Google Maps, Google Mail, all of this sort of showing that you can do web applications online and you can address use cases that are traditionally desktop use cases online. But there's still a large number of gaps. There's a large number of things that are possible to do in desktop applications, but not web applications, and that's what HTML5 is all about. And when I say HTML5, I do sort of mean it in the buzzword sense of all the APIs that are being added over the past 1, maybe 2 years. So 2009, sort of really the growth of HTML5, the growth of new areas, both in HTML, CSS, and JavaScript. There we go. So HTML5 is roughly these additions to HTML, CSS, and JavaScript. I'm going to talk about each of them briefly. So here we go. JavaScript APIs, new APIs being added. First thing up is new selectors. So for any of you who are sort of friends or old enemies with the DOM, you know that certain tasks that should be easy are not. For instance, finding elements by class used to be sort of difficult. Now there's a new selector for this. It sounds simple, get elements by class name, but it actually makes a lot of common things that web developers do easier. And that's really part of what HTML5 is about, is it's about looking at what are use cases that developers do, what are use cases that are common but people have developed hacks and workaround for, and how do we expose them. So these new selectors are an example of how we're doing this in both JavaScript as well as by adding selectors into CSS. And I'll get into those a bit more shortly. Come on. Web storage is sort of in the vein of what are things I can do on the desktop but not easily on a web application. So if you think about things like cookies, they were initially designed to give you some small amount of persistent storage on the browser so that you could do things like keep a shopping cart around, or at least keep a unique ID that corresponds to a shopping cart. But web storage is designed to sort of take that a bit further. So cookies are sort of a mess. Web storage is designed to provide you with a key value pair API for persistent storage on the client that actually works. And not only that, but it gives you a few cool bonuses, like you get events when something changes. So if you have, for instance, multiple tabs, you can have an event listener that'll get notified when one of these local storage elements changes. And I am not going to crash my browser and show this again, but if you were to type something here, I'll share the URL for the slides later so you can try it at home. This actually uses the local storage API to save this and bring it back up when the browser restarts. So key value pairs are nice, but what if I want more? I'm a web developer. I'm used to having MySQL or Postgres or some other SQL database on the server. We're also adding that into the client as well. So there's something called the Websql database that gives you a SQL database. In Chrome, this is actually SQLite in the client, so that you can do something like storing not only user preferences, but also more complicated data formats like email, where you might want to take the headers, the sender, the recipient, and break those out into different fields and actually be able to search on them. With the WebSQL database, this is possible. You can use the open database command to create a new database if it doesn't already exist. And then you can execute transactions. So not only do you have the ability to query and modify values, but you also have full transactional support, so that if you need to abort and roll back the transaction, that's possible. So storage on the client is nice, but if I'm always connected, do I really need that storage on the client? It turns out there's some use cases for this, but it's most useful in my mind when you're offline. So how do you make a web application that works offline? Well, the Application Cache API, or App Cache for short, is a way for you to specify what resources the browser should cache and make available offline. So that if the user goes to your web application when they're offline, the browser knows what resources to serve up from its local cache. And the App Cache API, again, is much more than just a listing of pages. It provides for more complex things like atomic updates. So if you're updating your application and you change some application logic that's going to break if not all of the files are updated, App Cache lets you deal with that, because with Application Cache, an update to the offline content is always atomic. It always all succeeds or it all fails. You don't have to worry about your offline application being updated into an inconsistent state because the update failed halfway through. That doesn't happen with App Cache. So how App Cache works is that in the HTML tag, you provide a manifest, which is a link to a file like you see in the lower half of the screen, that simply defines what resources should be made available for offline use. And there's a version number that you can update to, again, handle things like atomic updates. This slide deck actually uses App Cache, so I could present it offline, but I'm running a bit short on time, so I'm going to skip that part and move on to web workers. So on the desktop, we all are moving towards more capable processors that are multi-core or even multi-processor devices. So it makes sense to want to take advantage of this processing capability. And in desktop applications, you've been able to do this for years. You've been able to spawn up new processes and new threads. Web workers let you do the same thing in your web application. So from JavaScript, you can spin up a web worker to do heavy computation on a thread that's not the UI thread. So you don't have to lock up your application. Here we go. So here I have a little map, and if you're not using workers and you're doing all of your computation on one thread, things can be slow. So if we try to find a route here, 1, 2, 3, 4, 5, 6, 7, 8. This is taking a while. It's doing some computation. Who knows what's actually happening? So that took quite a while, and it came up with a rather complex route. If I instead do this using web workers and I move that computation off onto a background thread, 1, 2, 3, 4. This is much faster if you have a speedy network connection, I assure you. Not quite sure what's going on. Normally with workers, this is about 3 times faster. I'm just going to skip this part of the demo and move on. Live demos are always fun. So what else do web applications do? They do computation, but they also do communication back and forth between the client and the server. And traditionally, this has been done using things like hanging GET connections to wait for some data that the server might be sending, plus using a post whenever you need to send data back up. And it's traditionally very inefficient. With all these connections, you get all the overheads of headers. You have to encode your data, so usually people will take like a single letter or a word or a short sentence, encode it in some JSON format that bloats it up. Maybe everything gets base64 encoded as well. And then it gets sent using an HTTP post, and you get all the headers. So conceptually, although you might only be sending 3, 4, 5 bytes, just a word, on the server side and on the network, this can easily get blown up to a kilobyte once you look at everything like encoding and headers. Websockets is designed to provide for more efficient communication bidirectionally between your web application and the web server. So it's a socket interface that you can send and receive data on bidirectionally. So a single connection, you don't have to have two connections, you can have one connection open to the server. Either side can send data back and forth. It's efficiently encoded such that if you only need to send 5 bytes of data, on the wire it's 5 bytes plus some very small framing. It doesn't open a new connection each time. You don't have high QPS if you're sending a lot of data. You only have one connection that's held open without headers being repeated, so much more efficient. So the question was, can I give an example of using WebSockets? Anyone in the audience use either Google Wave or chat in Gmail? I see a lot of hands, that's good. So in Wave, each time you press a letter, we send that letter up to the server so that it can be displayed by all the other clients. In Gmail chat, it's roughly similar. Whenever you type, we send some of that data up to the server. So this turns out to be very inefficient because in chat what we're doing is we're using something we call browser channel, which is essentially 2 open connections, and we're encoding everything in JSON so that one letter that you type in Wave creates a form post to our server that is a new query. It has all the headers, and depending on the cookies, it's anywhere from 500-600 bytes up to a kilobyte. So that 1 byte got turned into a kilobyte. With WebSockets, we can keep a single connection open, and as you're typing, we just do post message with that letter. So rather than 1 kilobyte for every letter, we're now talking 5-6 bytes for every letter, because there's still some framing that denotes the length of the message, but it's much smaller. So this lets us do much more efficient communication between our web app and our server. Notifications. If anyone here uses Calendar, you've probably been as frustrated as I have when you get this window.alert that pops up and says, hey, you've got a meeting. But maybe I was off in another tab typing an email, and now my tab has switched. I can't even find what tab I was on. Window.alert is evil and should be banned. That's my personal opinion. So what we're doing is we're adding an API that we call notifications. And this lets you unobtrusively notify the user that something is happening. So for instance, you might want to know about new tweets that are happening. So I can request permission to display notification to the user, and now I have this permission. And I can now display notifications. So I'm going to type in Google here to see what we tweeted recently. And this is what the notifications look like. You get an unobtrusive little dialogue coming up from your desktop that doesn't change the tab, it doesn't steal focus, but you can still display relevant content to the user. So things like calendar notifications, new tweet updates. There's 2 versions of this API. One is plain text plus an image, another is HTML. So you could conceptually have an even more complex notification where you provide a form with options saying, remind me again in 5 minutes for a calendar invite, or change my response to this invite. So really a flexible API that's more powerful and much less annoying than window.alert. Drag and drop also turns out to be pretty popular in desktop applications. We want to support that on the web as well. So we're adding properties to the data transfer object for things like data so that you can get access to whatever is being dragged, whether that's from a web page or also from a file system. So I can take an image, I can drag it onto my web page and pull out all sorts of data from that. I can also do this from the desktop. So I could take an image from the desktop, drag it on to my web page, and get access to that image using, there's going to be a file object that I can get access to. And that will let you do all sorts of things like read the content of the file, get it as a binary blob that I can then put into Canvas. So I can actually take an image from the desktop, drag it onto my web page, and display it. You can do the same thing with text. So drag and drop, another cool API. Geolocation also turns out to be useful. We see a lot of location-based services popping up. You want to access the user's location. The geolocation API gives you a latitude and longitude pair that you can use You don't have to implement any IP-based lookup. That's all done in HTML5 for you. You just request the user's location, and if they agree, if they say, yes, I want to share my location with this website, you get back a pair of coordinates that then you can do whatever you want with. The API also lets you get updates if the user is moving. You can track the location. And if I demonstrate that here, hopefully this works. So I'm going to see, this site wants to track my location. I'm going to say allow. And now I'm going to get a Google map that hopefully shows me somewhere in Israel. It won't work in Israel. Okay, that's scary. Ah, thank you. Okay, well, at least on hybrid display, this actually is right where I am. This is Airport City. Thank goodness I am safe. Next. So just to wrap up with the JavaScript APIs we've added, we've talked about client-side storage in terms of WebSQL database, app cache, web storage. We talked about WebSockets, notifications, drag and drop, as well as geolocation. So those are new JavaScript APIs that were added. What else is here? Well, we've added a lot to HTML as well. So there's new semantic tags that let you actually mark up your document in a meaningful way. So you have a header tag if you actually want to specify what the header of your page is. You've got things like sections and articles, and the header can be a header of an article. So you can add much more semantic richness to your page to help things like automated agents better understand the content of your page. We've added things like link relations. So you can understand what is the icon for a page. You can understand if something points to the archives of a web page or if it points to the license for a web page. We've added microdata. So if you want to go all out and are really one of the semantic web people and want to tag up your page and say, I've got here a definition for a band object, and this is the name of the person, and this is the band that they're in, and this is the nationality of the person or the band. You can really go all out. So if you have more of a data-oriented website and you're looking for ways to mark up this data, there's a microdata section of the HTML5 spec, and there's a bit of back and forth around, what form does this data take? Is it RDFA? Is it something else? But the overall point is that HTML is now providing ways for you to mark up your data semantically. Also, if you're creating custom components and you've had accessibility issues, whenever we create new UI components, they're great if you can see the component, but if you're blind and you're using a screen reader, these things can be nightmare. So we've added support for ARIA attributes so that you can actually mark up your UI components and help screen readers understand what these components are so that they can actually be usable by people using alternative access methods such as screen readers. We've added new form types. So how many of you have ever done validation on things like a phone number or an email address? It's a real pain in the butt. Almost misspoke there. So we're adding in new form types that do not only things like validation, but also have new UI controls. So we have here an input type equals range that gives me a little slider, and as soon as I move this, oh, sorry, I'm not updating it. In the form, you can actually get access to whatever value is chosen here. I've got an input type equals search. It looks a lot like input type equals text, but I've got a cue that this is a search box, and if I'm an automated application, maybe I can pick up on this. I've also got things like, you'll see here I've got an input type equals number. This is failing validation right now because it's not a number, but if I change this to 12, now it's passing validation. So all that validation is built in. I don't have to write that in JavaScript. There's a number of other form field types that we're adding as we speak, including my favorite input type equals date that will give you a date picker, so you don't have to implement your own custom calendar thing. You can just say input type equals date. The user can choose it from a date picker. You'll have validation. That's going to be cool when it's done. Audio and video. It's trivial to insert an image to your web page. Image source equals whatever. We believe that video is also a first-class citizen on the web, and that should be trivial. So there's now the video tag, and we made a big announcement at Google I/O about WebM, which is a video codec that we're opening up royalty-free to the world so that everyone can use video on the web without even thinking about it. And with the video control, you get little built-in controls so that you can play the video. You can also script them via JavaScript, so I can do the same thing. This works for both video and audio. Canvas is another cool part of HTML5, so this is in HTML. It gives me a two-dimensional drawing object that I can use to draw custom things on. So I don't have to create everything server-side and send down images. I can create it client-side. So for instance, here I'm drawing a rectangle and filling it. I'm also drawing an arc. And there's, you can get really nitty-gritty if you want, and you can draw single points. You can also draw things like geometric shapes and curves. This is sort of a trivial example. What is Canvas actually useful in real life? So here's my photo. I can have no borders. I can have simple borders. I can have Polaroid borders. And again, I'm using Canvas, so I can redraw this. I can do the layering. This is a slightly more interesting example in my mind of what I might want to use Canvas for. So 2D is great, but what about 3D? If you look at a lot of games, on the desktop applications, things that make games cool are sexy 3D effects. We want to provide that same capability to web applications. So we've added something called Webgl, which is JavaScript bindings for OpenGL. So here you can see there's a 3D scene that's being rendered and played back. This is all in the browser. There's no plugins here. Whoops. If I right-click, you don't see Flash. This isn't fake. This is just JavaScript running in the browser, creating a 3D context using WebGL. So Canvas and WebGL are great, but what if I'm a vector graphic kind of guy? What if I want to do things that resize nicely? You've been able for a while to use SVG in most browsers. SVG provides you vector graphics that scale well. We're now adding that into HTML5 so that you can actually drop SVG right into your page. So you don't have to create a separate file. You can just include SVG context in your HTML and do something like draw a circle with a gradient. Or if you want to get more complex, you can draw a little tiger. And to show you that this is actually SVG and it scales well, here we can zoom in, and it's not getting all pixelated because it is SVG. It's vector graphics. So a big advantage over trying to do this in something like Canvas with raster graphics or bitmap graphics. So in terms of HTML, we've talked about adding semantics, adding accessibility, new form inputs, multimedia in terms of audio and video, as well as new drawing APIs. What about CSS? CSS we're also adding a lot to. We're adding selectors, which make, again, it's about looking at what do people do, what are the common things, and how do we make this easier. So we've seen people trying to do all sorts of hacks to do such a simple thing as, for instance, taking a table and coloring alternate rows in different colors. And so selectors now let you do this in a much more simple way. So there's a new selector called nth child, and you can get really creative with this. There's some defaults that are even and odd that apply to even and odd children. But you can also say something like 7 plus 2. And that'll give you all elements where there are 7n plus 2 elements before it, where n is any integer. So that would give you anything with 2 elements before it, anything with 9 elements before it. So if you're not happy with even and odd, you can get really creative here. But even and odd are sort of a nice demo to start off with. We're also adding new displays like inline block that'll let you have a div or any other element and have it work sort of like an image where it's an inline block element, text will wrap around it. Again, looking at what people are trying to hack around and make that possible. Also selectors for specific attributes. So selecting, for instance, in this example in the upper right, all input type equals text elements. And I'm not going to get into it because I'm running a bit short on time, but there's really complex ones as well. like specifying siblings and dependents of certain classes. You can get really fancy with new selectors in CSS3. They're cool. I'd encourage you to check it out. In terms of font support, we now support fonts coming over the web. So if you want to use a custom font, you don't have to render it as a graphic. You can actually specify a font to be downloaded. And here you can see this is not an image. This is this is text being rendered in that font. We can have text wrapping. So, before you've been able to do simple things, but now if I change the size of this, you can actually see that this text is being elided. This is done using text overflow. This is also cool, but, show me more. Now we have columns too. So multi-column layout, also a popular thing online, but can be difficult. Now you can, this is a new property in WebKit that we're hoping to standardize. You can specify a number of columns. So I can change it dynamically from 2 columns to 3 columns to 4. Everything works, it automatically gets relayed out. I can specify how I want the column rule, that's the divider here, to show up. So again, taking things that webmasters do and making it easier, making it built into the browser so that it's fast and you don't have to figure out how to do it in JavaScript. Other things, text stroke. You're going to see a lot of examples of things that typically you would have to do an image on the server side that you can now do on the client. Opacity. Here I'm going to change the alpha channel of the text. So the text is now fading, it's coming back. I can independently change the alpha channel of the background without affecting the alpha channel of the text. Again, this is something that has not been available on the client before, but on the desktop, you've been able to do this stuff for years. So it's, again, trying to provide similar capabilities that you have on the desktop to the web browser. Also have hue, saturation, luminance, running a bit short, so I'm going to skip that. Rounded corners, this is my favorite. We used to have rounded corners in Gmail, but it actually took us 9 DOM nodes to make a rounded corner. So this sort of caused memory bloat, it was slow. Now we have a way to do this in CSS. So if you watch the box below, my corners are now getting rounded. And this is one DOM element. I don't have to figure out how to do this myself. We're adding things like gradients so that I can change, again, more graphics dynamically. Adding things like shadows, so I can add a drop shadow. This here is specifying the X offset. This is the Y offset. And then this is some diffusion that's being specified. So all sorts of things now possible on the client. How do you put it all together? Well, maybe you want to create your next logo in HTML5. So let's take our logo. Let's add some sort of text shadow to that. We'll add a gradient. We'll add a border. And now let's reflect it. Ooh. So now I can come up with a cheesy logo really fast. I know everyone's excited by that. So, that's how you create images. What if you're trying to use images? What if you're frustrated with how your images scale? We now have a new property, background size, that lets you do things like contain, which makes sure that the image is fully contained, and I can resize this and everything's working. If I go along, you're seeing it's actually being contained on the x-axis, which is the larger one. If I switch now to cover, here my display area is always being fully covered by the background image. Transitions, also cool. So you've been able to use JavaScript to make things move around in the past. If I click over here, you'll see this little box on the top sort of show up on the right and on the left. But if I want it to be more graceful, if I actually want to show something animated, you can now use transitions in CSS to have something actually move over. And we're doing work to hardware accelerate this so that it will actually be a smooth transition rather than the jitter that you might see now on older devices. We also have things like transforms. So here I can do a rotation and scaling. I can also apply perspective to sort of zoom out a little bit and then zoom back in. All of this now possible in CSS. I showed some transitions. There's also animations, things like pulse. We're all hoping that it doesn't become the new blink tag, but it's there for better or worse. So CSS is changing as well. We're adding a lot for animation, typography, visual effects. So there's changes happening in HTML, in JavaScript, and CSS. All of these come together to form what we call HTML5. What's it all about? Well, it's really all about making sure that the use cases that are possible on a desktop application are possible for web applications. It's about making sure that things people have been hacking around for years and are sort of awkward, clunky, and slow are actually possible to do natively in the browser, are fast and efficient. That's what it's all about. That's what we're doing. How can you see it today? Well, you can use a modern browser like Google Chrome, of course, but a lot of mobile browsers are also implementing these HTML5 advancements. Things like the Android mobile browser, the Safari mobile browser on iPhone have actually implemented support for a lot of this already. And of course, there's Chrome Frame. My colleague Alex Russell just gave a talk over in the other session about how you can use Chrome Frame to enable these effects in browsers that don't yet support them. I'd encourage you to use your favorite search engine to find out more about Chrome Frame. So again, I'd like to wrap up. I know that lunch is starting in about 30 seconds, so if you run off to grab lunch, I won't be offended, but if you want to ask questions, I will stick around. Thank you so much. Definitely appreciate you all coming out. Question in the front. The question was, does Firefox support all these standards? With everything, someone has to go first. So a lot of these Firefox have been intimately involved in. So for instance, Webgl, Firefox is heavily involved in. They're one of the editors on the file spec. So by and large, all of these are going to show up in Firefox at some point. The one exception that I'm aware of potentially is the Websql database, where we're arguing about whether SQL is a good idea. And there's a valid argument there. I mean, if any of you have ever dealt with transitioning from MySQL 3 to MySQL 4, you know that database upgrades can be painful. We're going to have the same issue in the browser if we don't specify the actual dialect of SQL. Right now the spec just says you have a SQL database. Well, what if someone doesn't want to use SQLite to implement? Or what if they want to move from one version of SQLite to the other? This is Firefox's current objection to the SQLite spec. We're working on that. We're also introducing a new database API called the Web Index Database to sort of try to get around that. But by and large, everything that you see here will show up in all browsers pretty soon, and a lot of it is already there. Can I implement these now without breaking the application for other browsers? Yes, so things like rounded corners you can of course use and then fall back if you're doing user agent detection, fall back on a browser where it's not supported. Things like drag and drop, if you implement support for drag and drop and the browser doesn't support it, well, you're not going to lose your whole application. So I think the key thing to remember here is that although not all the browsers support everything yet, you all are actually in the driver's seat. So if you see something that is compelling, if you see an API that you think is cool, go ahead and use it. And that will force browsers to implement it. It'll force them to prioritize, because right now, we all have finite resources. We pick and choose what to implement based on what we think is most compelling and what is most likely to be used. But if we see an API that's actually starting to be used, that's going to jump way up on our priority list. So please, don't wait for everyone to catch up. Go ahead and start using these APIs where they're available, and the browsers will follow. What's that? Modernizer.js. Yes, back there. Can I repeat the URL for the presentation? So these slides are available at slides.html5rocks.com. And on html5rocks.com, we're also putting up a lot of examples, tutorials. We're going to have like a developer playground there as well. So html5rocks.com, we're sort of pushing as a resource for all things HTML5. These slides and much more are available there. Yes? So the question was, are the network connections firewall safe? I'm assuming you're talking about WebSockets. It's designed to work through firewalls. So the way it actually works is that it starts off as a HTTP connect, and then we do an upgrade request. So by starting off as an HTTP connection and then upgrading, we're able to get pretty good results on going through things like firewalls. We did a test where there's 3 different things you can do. You can either use WebSockets on port 80, you can use WebSockets on port 443 using SSL or TLS, and you can use WebSockets on an arbitrary port if you want. When we tried doing it on port 80, we didn't get good results. When we tried an arbitrary port, I think it was slightly better. When we tried using encrypted WebSockets on port 443, I want to say we got something like a 99% success rate for connections. So it does work for things like firewalls. That was designed into the spec. Any other questions before everyone runs out to lunch? See one in the back. Does WebSocket need server-side changes? And the answer is yes. You can't use WebSockets to connect to just any random port on any random server. It has to speak the WebSocket API. We have something that we call mod WebSocket that lets you use WebSockets in Apache. We're also working with others. There's a number of companies that are developing WebSocket servers as well. So yes, server-side changes are required, but we're seeing good progress there. And one back there. I'm sorry, could you scream it out a bit louder? So how secure is the SQL connection? You mean for things like SQL injection and whatnot? Or? So the JavaScript database is per origin, so no one else can access your database, if that's what you're wondering. The database that you create in your origin is only accessible from JavaScript running in the same origin. So you are protected there. But given that it is an SQL database, you do have to worry about things like SQL injection that would compromise your database. You do have to worry about things like cross-site scripting. So, you know, it comes with all the same caveats that you have with server-side SQL. All right, I'm going to wrap it up because I know people are waiting to eat. I'll hang around over there. Thank you all so much for coming. I appreciate it.